Okay, now that you've learned the alkanes, the alkenes, and the alkynes, let's look at some of the physical properties, because some of the things are going to be similar between these three different families, and then there's going to be a little bit of difference, variation in there that you need to know as well. So the first thing you need to look at is in your notes that the boiling points increase as the carbon content increases. So if you were to have, for example, a 4-carbon molecule like this one, and then a 6-carbon molecule like this one, I would never ask you to tell me exactly what the boiling point is, but you should be able to tell me that this hexane is going to have a higher boiling point than that butane because of the larger carbon content. More molecules, more atoms, the higher the boiling point. So the bigger they get, the more carbons there are, the higher the boiling point is going to be. So that's the first thing you need to know. There is some variation between the families. And the way I remember this is by remembering Y-A-E, kind of like yay. And that's because the alkynes are slightly higher than the alkanes, and the alkenes are lower than the alkanes. So if you had 4 molecules, and I've given you 3 in that box to the side there. Let's say you have ethane, ethene, and ethine. Well, according to Ye, ethine should have the highest boiling point, and then ethane, and then ethene. And that would be true. That's what we actually see. If we look at the numbers, ethine has the highest at negative 84 degrees Celsius. Ethane has the next highest at negative 89 degrees Celsius. And ethene is at negative 104 degrees Celsius. It has the lowest. Now, I would never expect you to pull out those exact numbers, but what I might expect you to do is put them in order, and you would have to say that ethine has the highest, in this case ethene has the lowest, and the ethane would be the middle. So depending on whether I said ascending order, meaning getting higher, or descending order, getting lower, you would change the order you put those on, for example, in a numerical response question. Now, I'll typically only ask questions that do one or the other. I'll ask you to compare the anes to the enes to the ines if they're all the same, right? Meaning they all have the same number of carbons. So they're all 4-carbon molecules, but one's an ane, one's an enes, one's an ine. Or I'll have them all in the same family, like they're all alkynes, but they're different sizes. So maybe a propyne, a pentyne, and a heptyne. So it's going to be one or the other. I won't make you mix those two because that gets too complex. It'll either be, can you compare different families that are the same size, or can you compare the same family, that we would call that a homologous series. Hopefully we'll come back to that term some more. But the same homologous series, which just means the same family. You might want to even write that in your notes somewhere. But different sizes. So they're all alkanes, but they're just bigger or smaller. You just put them in order based on their size. Okay, melting points of the alkanes, enes, and ines are fairly low. And state of matter depends on their size as well. So 1 to 4, so meth, eth, prop, bute, those are all gases at room temperature, and that's true of the anes, enes, and ines. From 5 to 16, they're more of a liquid state. Over that, you get into really heavy liquids and eventually even into nearly solids or even solids, depending on how dense these molecules are. But the bigger they are, the more solid their state of matter is going to become. So gas for those first 4, then liquid, and then eventually down to like asphalt and tar, all nearly solids. You also do need to know some common molecules for this. So they will expect you to know some organic molecules that are just kind of common, everyday kind of molecules. So the ones from your notes from here that you should know are that methane and ethane are essentially natural gas. So the thing that's heating your home, your hot water tank most likely, most of our heating kind of stuff around here runs from natural gas, which is a combination of methane and ethane. You should know that propane is the fuel that we would use in barbecues and things like that. Butane is found in lighters and some torches, things like that. Ethene is also called ethylene. That's one of the common names. You don't necessarily need to know that common name, but it's a natural fruit hormone that's given off. So if you've ever noticed when you go to the grocery store and buy fruit, if it's already in a bag, let's say a bag of grapes or something like that, that bag will have holes in it, or it'll be in some sort of a mesh. And the reason that they do that is because if they don't put it in that mesh, the plant naturally gives off ethene or ethylene. And that hormone makes the fruit ripen faster. So if you took a banana and you put it in a Ziploc bag and then you put another banana beside it that was just laying out on the counter, the one in the Ziploc bag would ripen and then go past ripen, go bad faster. So if you buy fruit and they didn't have those little openings or that mesh bag around the fruit, if they had it zipped up in a plastic bag, the produce would actually go bad. It would ripen faster, but it would also go bad faster. It would spoil. And so that's why those bags tend to have either a mesh or holes in the plastic bag. It's also why when you buy groceries, take your produce home and take it out of the little plastic bags that you may have put it into, so that that ethene can go away from the plant so it can mix in the room. It's not harmful, but it'll make your fruits or vegetables stay good longer without going bad. And the last one you need to maybe know is ethine. And ethine is also called acetylene. So acetylene torches or welders, if you've done anything in the automotive shop, you've maybe done a little bit with acetylene, but that's basically the fuel that they use for that. So this is just some of the basic properties. They will expect you to be able to look at, like I said, comparing different families' boiling points if they're the same size. The homologous series, or the same family if they're different sizes. Make sure you know how to do those boiling points. Make sure you know some of these common molecules, because they will expect that you just know those. They won't tell you propane. They might just show you a barbecue on a question and you'll be expected to know that that's the molecule being used. And that's about it. So if you have any questions about anything about the physical properties of these molecules, let me know.